If you shake, then you get cookie. Shake. Oh, that's a good girl. Hi, welcome to Conditionals. Let's do our lab walkthrough right now. Okay, let's take a look at 1-1. So if you look at the code before we do 1-1, it gives you an example of how a conditional statement might work. Well, I have an extra parenthesis in there. Take that out. Where I enter a number, and it tells me that that's odd, or I run it again, and I enter another number, and it tells me that's even. And the way it works is there's an expression up here, a Boolean expression. It evaluates a true or false. And this expression says, if the number, when we divide it by 2, has a remainder equal to 0. So when you divide an even number by 2, it'll have a remainder of 0. If you divide an odd number by 2, it'll have a remainder of 1. And the else statement doesn't need a condition, because if this is not true, because Boolean means true or false, if this is not true, it will just do the else part. So let's see if we can debug this code here, which is asking us to print 0 or positive when the number is greater than 0. Otherwise, print negative. Now, there's a couple things that you should notice about the if statement. You see how the values under the if and under the else are indented in. They're not like this. They're over like this. That is required by Python. This is what's called block indenting. And what it says is that this code only executes when this part is true. This code only executes when this if is false, because that's by definition what else does. So armed with this knowledge, let's see if we can go ahead and debug this code. First of all, I like to just run it, see what happens. And I have an indentation error, line 6. It helps to turn line numbers on. And as we saw up here, you must indent the block of code under else. And anytime there's a colon, Python is expecting you to block indent the next line. Okay? That doesn't mean that the next statement after it needs to be block indented. That statement could occur under there. If the statement is here on line 8 or on line 7, even with the else, it will always do this. Whether or not it does line 4 or it does line 6, it will always do line 7. I'm going to leave that there just so you see. Okay, let's see if we can get this thing to work here. Enter an integer, so 10. 0 or positive. So I entered 10, and then if 10 is bigger than 0, that's true. It prints 0 or positive. And then on line 7, it prints high, regardless of whether it's true or false, because this is not indented. If I indented it, it would only print high under the else. Let's run it again, because you have to run it twice to make sure it works. Let's enter minus 90. That's negative. And then again, it prints high because that's not indented. Okay, that's 1.1. All right, let's look at 1.2 now. 1.2, we will start to build out a game of rock, paper, scissors. And you probably know this game or have played it as a kid, where you go rock, paper, scissors, shoot. Oh, rock smashes scissors, so scissors loses. Or paper covers rock, right? There's all these rules. So we're going to actually implement this game where you play against the computer. And in the first cell up here, we import random, and then we have a list of choices, either rock, paper, or scissors. And then this code here says select a random choice among our list of choices. So if you run this code, it says scissors, and you run it again, and it says scissors, and you run it again, and it says rock. So it's picking one at random every time. Eventually, it will say paper if I do it enough. Pardon me. Maybe I have to do it for a long time. There we go. Now it says paper. So it will always pick a choice at random. That's what that code is doing. So then down here is how you get your choice, right? You pick. You know, the computer picks, then you pick. And then I pick rock. And then you chose rock, and the computer chose scissors, so I win because rock smashes scissors. So then in the guarding against stupidity section, we deal with the fact that we do not want you to enter something other than rock, paper, or scissors. We try to handle that with a Boolean expression. So there's an operator called in, which will check to see if a value, like rock, is in a list of values choices. So rock in choices or Mike in choices. So rock is in choices, but Mike is not in choices because rock, paper, scissors. So rock in choices is true. Mike in choices is false. So now down here in 1.2, we can figure out how to write this code so that when you type your input, we use an if to make sure you enter either rock, paper, or scissors. So if you look at this code, see what's important is not only being able to write code, but also being able to read code. And in the lab, you have to read a lot of code. So we saw this before. The computer picks a choice. Then down here, you enter your choice on line 7. And then on line 9, what I want to do is I only want to print this if you picked rock, paper, or scissors. Otherwise, I want to say you didn't enter rock, paper, or scissors. So I need to figure out what to put right here in to do. And the hints are obviously in what we did up here, right? So like rock in choices, Mike in choices. So where is my choice? My choice is in you. You has my choice. So I'm going to say if you in choices. Right? Choices is merely a list of choices, rock, paper, or scissor. And then you is what I typed. And I want to make sure what I typed is in that list. Otherwise, you can't play the game. Because you can't say computer beats rock. Because computer's not a choice. Okay? So let's see if it works. People. You didn't enter either rock, paper, or scissors. See how that works? This is a way to do input validation. Something that we were looking at last week. How do we do that? Well, we don't know. We're going to learn this week. So now this week we learn how to do input validation. So enter your choice, rock. There you go. That's 1.2. All right, now here in 1.3, we're starting to implement the program itself. Before 1.3, there's some sample code where I handle the rock case. And if you don't know how to play the game, it explains how to do the cases up here. So rock beats scissors, scissors beats paper, paper beats rock. So if you choose rock and the computer chooses paper, you lose because paper covers rock. This is all too complicated to do at once, so the right thing to do is to do it in bits. So this is the first part that was written for you, and it handles the rock case. So if you run it, it says you chose rock and the computer chose rock. It's a tie. Now, normally you would be typing in rock, but on line 8, I commented out the input because I certainly don't want you to have to keep typing in rock over and over again to make sure the program works, right? Once you know the program works, you can put the input back on so that you can actually play the game, okay? So you chose rock, computer chose rock, it's a tie. That's this one down here. That's this case down here. You chose rock and the computer chose scissors. So if you equals rock and computer equals scissors, then it's going to print you win, rock smashes scissors, which is right here. You win, rock smashes scissors. And then let's see if we can get the last one. You lose, paper covers rock. You equals rock and computer equals paper. So you lose, paper covers rock. So those are all 3 cases for rock. Now in 1.3, you have to write the cases for scissors. Okay, and you can see my rock cases are here. Now, why am I using if, elif? Because we really only want to make one of these decisions. We don't want to make a decision that says paper covers rock and then rock smashes scissors. We don't want to show both of those. So we use if, elif, because the way if, elif does is it says, is this true? Okay, no. Well, is this true? No. Well, is this true? No. Well, is this true? No. Okay, well, I'm going to do this else. Okay, and that's basically what the if, else, if, elif structure does, is it allows you to make a series of decisions. That's why we call it an if, else ladder. It's like rungs in a ladder. You can't just go from 1 to the end. You have to go up each rung in the ladder. So that's why it's called an if, else ladder. We have the 2 rock ones, and let's take out let's look at the paper ones. If your paper and the computer's rock, what should this say? Should you win or lose? Paper, you are paper and the computer is rock. So paper covers rock, so you win, right? So we should say, here we should say you win because paper covers rock. I guess I don't need a capital there. If you're paper and the computer is scissors, you lose because scissors cuts paper. So this should say you lose scissors cuts paper. All right. So now we change our input to paper. We already tested the rock case. So now we have to test the U paper case. So we have to run this until we see all the U paper cases, right? And I have an error here. This is something I do a lot. I forget colons on the ends of my ifs, right? All of these ifs. Anytime you indent, you need a colon on the line above it. That's the rule of Python. You win. Paper covers rock. Okay, there's one case. You win. Paper covers rock. You win. Paper covers rock. It's a tie, so we both chose paper. It's a tie. You win. You lose because I chose paper. The computer chose scissors. So you lose. Scissors cuts paper. Okay, so I tested all three cases there. See, as you use conditionals, your program gets a lot more complicated because you must verify that each of the branches that you may potentially take in the program is correct. That is 1.3 U code. All right, in 1.4, we are tasked with completing the program by writing the scissors cases, right? Where you choose as input scissors. Boy, if I could spell scissors, that'd be dangerous, right? So we need to think through what kind of ifs we need to do that. Now, if you look for any case where we have like rock or paper, there's two conditionals, right? So I know I need to add two conditionals here. ELIF, right? So the question is, what conditionals and what do we do with them? Well, we already did rock, we already did scissors, so now we're doing, or paper, so now we're doing scissors. So I'm going to go to this to-do line. I'm going to press enter, and I'm going to type elif, and then let's say U is scissors, and computer is, now it's got to be rock or paper, right? Because scissors is a tie. So U scissors, computer, paper, colon, enter. What do we say? On line 17, we're going to say who wins. Print. You have scissors. Computer has paper. You win because scissors cuts paper, right? You win. Scissors. I'm tired of typing it incorrectly. Cuts paper. Okay, so I should probably fix this one up here. It says paper beats rock, paper covers rock, scissors cuts paper. Okay, now I want to do another elif. So when I hit enter, see where it puts me? So to get back, I hit backspace. I can also hit shift tab, either way. And now I can type in elif again. And in this conditional, it's going to be U equals scissors. And computer this time is going to be rock. Print. Okay, let's figure this one out. You've got some scissors. The computer has a rock. Rock smashes scissors. You lose. You lose. Rock smashes scissors. All right, and I don't need all these extra spaces in here. Now I need to test it. Up here where we have line 4, I'm going to put scissors for you until I know that the scissors test case works. And I've got an error here. It's double equals for equal to, right? This equal means take scissors and put it in the variable u. We don't want to do that. Double equals. Okay, scissors, scissors, tie. Scissors, scissors, tie. Scissors, scissors, tie. Okay. Scissors, paper. You win, scissors, cuts, paper. Okay, let's get a you lose. Holy moly. You lose, rock smashes scissors. Okay, so all of the cases are in there, and now the game can be played because I have all the cases in there and we can give it a real... Let's run it. Enter your choice. I'm going to beat this computer bad. Paper. You chose paper, computer chose scissors. You lose. Ah! Let me try it again. Rock. You lose. Paper covers rock. It's like it can read my mind. It's crazy. I'm kidding. That's 1.4 code. Okay, in 1.5, we are tasked with writing a program on our own. The algorithm is up here that we should do. But before we get into that, let's explain this whole exceptions stuff. So the way exceptions work is they handle errors that occur at runtime. So for instance, when I run this program and it says enter your GPA and I enter 4.0, it has no problem with that. Right? Or I enter a 2.5 and it has no problem with that. Now if I enter my GPA is low, that blows up with a value error because it's trying to convert LOW to a float on line 1. See the arrow points to line 1? And it can't do that. So, you might be wondering, how do I handle these kinds of errors in my code? This is a last mile problem. You write your program and then you like polish it up real nice by adding code to handle errors. You don't start by handling errors. That's kind of the wrong way to go about it. Okay? The way you do it is you take the code that you want to handle the error in and you put it in a try, and then you accept the error that happens and then take action on the error. So now if I run it and I put in that for a GPA, I don't get an error. Instead, I get a nice message that prints instead. You can access the error itself, by the way, by giving it a variable name. If I said value error as E, that actually takes the error and puts it in a variable so that I can print the variable out if I wanted. Let's print E. And it says could not convert string to float. Right? So you get some details. That's useful because maybe what you want to do is you want to print a friendly message and then maybe you want to print the actual error. Whoops, boy, my fat fingers. Like that. Here, maybe I'll call this details. Right, so you enter that in, it says error that is not a valid value for GPA, details, could not convert string to type float. So that way you're not hiding the underlying error message itself. Gives you a little hint as to what's happening from a Python standpoint. But this is the friendly error message, the one that you really want to show people so that they know what happened. So now let's move on to 1.5. So in 1.5, you are tasked with entering a number and then letting us know whether it's positive or not positive or not a number. Positive, not positive, that's easy. That's a regular conditional. If input number greater than 0, print positive. Okay. The way you handle not a number is with try except. Okay. So let's go ahead and write it. Now, first thing I like to do is I always like to write it without the try except. Right? So I'm going to input a float. If number greater than 0, print positive, else print negative, print not positive. So I'm going to do that. So number float input, enter a number. If number bigger than or equal to 0, print positive, else print not positive. that is the program with expected inputs. So if you expect the inputs to work, this is what should happen. Positive, not positive, right? Now, if you enter an input that we don't expect, that's not a number, it blows up. So the way you can handle these kinds of errors is only with try except. So you might be wondering, what do I try? Do I just try this, right? Do I try this and then the if? You know, where do I go? Basically, if you have to think about this, if this doesn't work, does any of this make any sense? No, because all of this stuff depends on having a valid number. So all of this stuff goes in try for that reason, because this code depends on this code. This code is what throws the error. And therefore, none of this other code makes any sense if we get that error. So that all falls under try. You might be wondering, hey, Mike, how did you move that stuff over so quickly, right? So check this out. I'm going to type try, and then I'm going to highlight my code, either using my mouse, or I like to hold down Shift with the arrow keys, and then you hit the Tab key to move it over. Pretty cool. And then I'm going to add an accept, and it's always going to be the error that you need to accept. In this case, it's value error. And when I have my value error, I'm going to print not a number. Not a number. Okay? That is 1.5 code. Well, congratulations, you made it through another lab walkthrough. Thank you for your time. I hope it was helpful. Goodbye now.